Trigonometry is an interesting branch of geometry that has to do with relations between sides and angles in a right triangle. This branch of geometry stems from the fact that two triangles with the same angles are always similar. Today we will be talking about three important ratios based on this angle, angle C. Note that all angle measures will be in degrees. The first ratio is the ratio between the opposite side and the hypotenuse. Because these two triangles are similar, BD over BC equals AE over AC. This ratio is called the sine ratio. The sine of an angle is equal to the opposite side over the hypotenuse. The graph of the sine function looks like this. There are some triangles where we can use other geometric principles to find the sine of an angle. For example, from a 30, 60, 90 triangle, we can find that the sine of 30 is 1/2 and the sine of 60 is half the square root of 3. From a 45, 45, 90 triangle, we can find that the sine of 45 is half the square root of 2. The second ratio is the ratio between the adjacent side and hypotenuse. The adjacent side in this case refers to the adjacent leg. For this triangle, DC over BC equals EC over AC. This is known as the cosine ratio. The name cosine comes from the Latin complementi sinus, meaning complement of sine. This is a fitting name because the cosine of the complement of an angle is equal to the sine of the original angle. The graph of the cosine function looks like this. It is nearly identical to the sine function but slightly shifted. From a 30, 60, 90 triangle, we can find that the cosine of 30 is equal to half the square root of 3, and the cosine of 60 is 1/2. From a 45, 45, 90 triangle, we find that the cosine of 45 is equal to half the square root of 2. 45 degrees is the only acute angle measure for which sine and cosine are the same. The last ratio is the ratio of the two legs, specifically the opposite over the adjacent. In this triangle, BD over CD is equal to AE over CE. This ratio is called the tangent ratio, also known as tan. The tangent is equal to the opposite side over the adjacent. This is also equal to the sine over the cosine. Because sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, dividing them with normal fraction rules results in the hypotenuse getting cancelled and leaving opposite over adjacent. From a 30, 60, 90 triangle, we find that the tan of 30 is equal to 1/3 the square root of 3, and the tan of 60 is equal to the square root of 3. From a 45, 45, 90 triangle, we find that the tan of 45 is equal to 1. This makes sense as the sine and cosine of 45 are equal. We can also find another interesting property of the tangent, this being that the tangent of a number and the tangent of its complement are reciprocals of one another. These trigonometric functions can be used in many ways. They are very useful in physics, astronomy, surveying, architecture, GPS, and of course teaching math, among other fields. There are some other trigonometric functions called secant, cosecant, and cotangent. I encourage you to learn about these functions as they are also very useful. I hope you enjoyed this video and I'll see you next week for another one.